Hey, class, this is lesson 4.6, formalizing relations and functions. You will learn how to determine whether a relation is a function and to find domain and range and use function notation. Some of you were wondering on the last thing if you had to use function notation. Now you will have to know how to do that after this lesson. So let's put some of these words in here. Domain. X values, input, equation is the function rule, and output, the y values or the range. All right, one way you can tell if a relation is a function is by mapping it out, and if any of the inputs, which we shall call domain from now on, map to more than one output, then it's not a function. So we're going to check these separately. So this is a relationship between numbers. The x values are the inputs or the domain. So I'm going to write domain here, range here. And for letter A, my domain is -3, 0, 1, and 2. And my range is 1, 2, 1, and 4. So 1, 2, 4 for the range. And that's these values, the y values. And now I'm going to map them. -3 goes to 1, that's the first order pair. 0 goes to 2, that's second order pair. 1 goes to 1, and 2 goes to 4. And if you see more than one arrow from any domain value to two different range values, then it would not be a function. But in this case, we only see one arrow coming from each domain value. So, yes, this is a function. All right, let's try the second one. You might have to redraw something to do the second one. I'm just going to erase this. And the second one, so this is our domain again. This is our range. In our domain, we have 4, 5, 7, 5. So 4, 5, and 7. And in our range, that's our y values. We have a 6, a 1, and a 2. And now if I map those, 4 goes with 6, 5 goes with 1, 7 goes with 2, and 5 goes with 2. And if you look closely here, you will notice that from the value 5, there are 2 arrows. So 5 maps to 2 different outputs. There are 2 outputs for 1 input. This is not a function. All right. Another way to decide if a relation is a function is to analyze the graph using the vertical line test. If any input value has more than one output value, then those two values will line up on the graph vertically. So if we pass a vertical line through the graph and we hit no more than one value, then it's a function. So we're going to graph set A on this first graph here. So we have -4, -4, -2, 3, 3, 0, 5, 1, 6, 1. And we're going to use a vertical line. If I take this vertical line and I hit more than one point at any place along the x-axis, and it's not a function. But you'll notice with this that the most I hit is one value. So, yes, it's a function. All right, second one, we're going to have to generate some values for that one. So I'm going to make a table of values. I'll use my vertical line here. Make my table. And the input values I'm going to use are the input values we have along the x-axis here. The second graph. So -4, -3, -2, -1, 0, 1, 2, 3, and 4. So, and if I plug those into the function 2x squared plus 1, so I'm going to take -4 times itself, which is 16 times 2 is 32 plus 1 is 33. -3 times itself is 9 times 2 is 18 plus 1 is 19. -2 times itself is 4 times 2 is 8 plus 1 is 9. I'm going to pause here. And so here's the function. Since my range or my domain for this value is really all real numbers, so I'm going to connect the dots because we could have values in between these also. Put arrows on the end, that would continue. Now I'm going to borrow my vertical line, and if that touches the line in more than one place, then it's not a function. And we can see that it would only touch it in one place. And if x goes up at all, y will be a bigger value, so you never would get more than one. The line won't curve back. So, yes, it's a function. All right. Below is an equation written in function notation. I gave you a little taste of this in the last lesson. Notice that we say f of x when we say that, and all that is saying is that this is my function, x is my input. So I'm designating x as the independent variable. So to evaluate a function, we want to find out how many words Rachel can type in X minutes, and so how many can she type in 7 minutes? So here's my original function. And all I need to do to figure this out is substitute 7 for X. So T of 7 means when the input value is 7, what is my output? And I'm going to substitute 7 for X here also. And I'm going to go ahead and multiply that out. 65 times 7 is 420, and 35 is 455. So how many words can she type in 7 minutes? She can type 455 words. And that's what this notation designates. the number of words in 7 minutes. What is the range of f of x equals 3x minus 2 with the domain 1, 2, 3, and 4? The range is the output or the y values. So we need to find the y values when the x values are 1, 2, 3, 4. I think the easiest way to do this is to set up a little table, put in our input values, then we're just going to substitute that input into the function for each of these values. And evaluate those. And we get 1, 4, 7, and 10. So those are my range values, otherwise known as the output or the y values. All right, identifying a reasonable domain and range. We're going to use the problem to help us figure that out. And our domain represents our input, or our x values, independent variable. In this case, it's r. And it says that she has 4 rows to work with, so she can use anywhere from 0 to 4 rows. And in mathematical notation, we would say the domain is r has to be greater than or equal to 0 and less than or equal to 4. Now the range, the least we might use is 0. So we want to find f of 0, which is 30 times 0, which is 0. The most we would use is 4. So we want to find f of 4, which is 30 times 4, which is 120. So we would say our range, the least is 0. And remember, that's our output, so the whole function, the most our function value could be is 120. And the graph would look like this. It would start at 0, end at 4 for the inputs, or 120 for the outputs. And the lesson check. And that should do it.